All right, so on question number 5, we're looking at the weights of packages that can be anywhere between 14 and 20 pounds. So it says a package delivery service divides their packages into weight classes. Suppose that packages in the 14 to 20 pound range are uniformly distributed, and so that means all weights are equally likely to occur. So what we are looking for here, I don't know what happened to part A, but it says find the probability that a randomly selected package will weigh between 15 and 16.5 pounds. So when you're talking about a continuous variable and your probability distribution is in a graph, as this one is, the area over a range of values like 15 to 16.5, for example, is going to be your probability. So what I would do on a question like this, and make sure when you take the test you have scratch paper out, I think that's really important. I would make a little sketch here and I would just say, okay, 15 maybe is like right here and 16.5 pounds maybe is right here. So we're looking at the area bounded within the larger rectangle, within the larger distribution between 15 and 16.5 along the x-axis. So to do that, I'm going to calculate the area of that rectangle. Well, that would be the length times the width of that rectangle. The length would be 1.5, right? Think about that. That's just 16.5 minus 15, right? And then the width would be the 1/6. So that would be the height this way, right? 1/6. So length times width. So if we go to our calculator and we do 1.5 times 1/6, I'm getting 0.25. And so that should make sense because probability, remember, has to be between 0 and 1. In decimal form, that would be the same as 25%. There's a 25% chance a package will weigh between 15 and 16.5 pounds. Part C says, what is the probability the package will weigh at least 18 pounds? Well, 20 is the most that a package can weigh. So 18, maybe 18 is like over here. Here, let me clean this up a little bit so you can see where I'm getting these numbers from. Let's say that 18 maybe is like right here. Over 18 pounds, or at least 18 pounds, would be from 18 to 20. It has to be. So it's going to be same deal. We're going to do length times width again. So the length would just be 2 this time, times 1/6. So that would be 2/6 or 1/3, or about 0.33 or about 33%. So there's about a 33% chance that a package will weigh at least 18 pounds for this distribution. So when you see a question like this, you're looking at areas. And when we talk about normal distribution, and actually that's what's coming up in the next section, we're looking at a normal distribution. Normal distribution is a measurement of a continuous distribution. It's a measurement it's the probability, rather, gives all the probabilities for a continuous distribution of some kind. It just follows this special shape that's normal. And so, or follows this normal curve, I should say. So look at number 6. It says, if the area under the standard normal curve. So first of all, you need to know what that is. The standard normal curve is a special normal distribution with a mean of 0 and a standard deviation of 1. So that's something to be aware of, that when you hear the word standard normal distribution or standard normal curve, it's a special normal distribution where the mean is default to be 0 and the standard deviation is defaulted to be 1. It says the area to the right of z equals a. Usually we use z-scores to describe the standard normal distribution. The area to the right of a is 0.0329. Okay, so what you want to think about is, where does that force a to be if the area to the right of it is 0.0329? Think of that like a percentage. That's only 3.29%. That's a very small percentage. So if the area to the right of something is only 3%, that means that that A has to be somewhere over here. And that 0.0329 is the shaded region. The area, remember, is what gets shaded. So that's 0.0329, that shaded region in blue. And then it says, what is the area then to the left of negative A? Well, think about the symmetry of the curve. The normal distribution is symmetrical. If positive A is over here, that means negative A has to be over here. So the area to the left of negative A would be this region right here. And again, think about the symmetry of the graph. That means that that area is 0.0329 as well. They didn't say to the left of positive A. To the left of positive A, that would have been all of this, right? That would have been the complement. They didn't ask for that. They said the area to the left of negative A. So negative A has to go on the opposite side of the graph and be symmetrical. So the area to the left of it would be the exact same as the area to the right of positive A, 0.0329 again. Okay, that's why the picture for these is so important. Take a look at number 7. If the area under the standard normal curve to the right of z equals negative b is 0.8340. Now this question I think is a little confusing because they went ahead and told you that b was negative. And even if they didn't, what I want you to pay attention to is that the area to the right of whatever z-score is 83% of the graph. That's a big chunk of the graph. So that means I have to be somewhere over here. They're telling me the area to the right of it is more than half the graph. It's 83% of the graph. Part of this is just really understanding what these terms are referring to. So 0.8340 is all of this information and all of this shaded region over here. So that's 0.8340 and says, what is the area then to the left of negative b? So that same location, they want the area to the left of it. Well, that would have to be the complement of the 0.8340. So 1 minus 0.8340, 17, 16, let me make sure. I just never trust myself when I'm trying to do this stuff in a recording. 0.8340, yeah, that's what I was thinking. Okay, so 6.166, so about 16.6% if you want to make it a decimal, although, I mean a percentage, but a decimal would be fine as well. Draw a picture for these questions. I think these are important to do with a picture. All right, let's look at number 9. Number 9 gets into the empirical rule. And just like on the last test, I told you to write down those subsections of the empirical rule. I highly recommend that you do that again for this test. When you have a normal distribution, obviously it's symmetric. So the empirical rule definitely applies to any symmetric distribution. So they're telling you in this case, we have a normal distribution, the mean is 100, the standard deviation is 15. So there's a nice little output here of StatCrunch. And I'm going to go ahead, before I even look at the questions, I'm going to subdivide all these regions because I feel like this is so important. I want you to have this on your index card. This is very, very, very important. So let me try and make that a little straighter. Okay, so we've got, let's see. So we've got, and I don't go by what's in red. The red is a special region that goes with, I think, question A. I want, sorry, it's hard to do with a tablet. Okay, I'm going to just try to subdivide these. I'm trying to ignore the part in red. All I want you to focus on is the region. You know what? I'll tell you what. Let's do it this way. Let me instead draw just an entirely separate graph, a generic distribution. It's a normal distribution, and let's label the subsections again using the empirical rule. Okay, so here we go. Mu is in the middle, 1 below, 1 above. Remember that that is 68% of the data. So each side of the mean is 34%. And then if I go 2 below and 2 above, remember that that's 95% span of the data. So there's 95, take away 68. I think there's 27% left for each of those little sections. If you divide it in half, that's 13.5. And then if I go 3 below and 3 above, it's 99, I think it's like 99.7 something percent. I don't know. But if we're doing it by hand, we just basically say it's 100% of the data set. So that means you've got 5% remaining for the tails. So that's 2.5 there and 2.5 up there. All right, now let's go back to the questions here. It says, find the probability that a randomly selected person would have an IQ score between 84 and 128. Now, we're not trying to trick you here. This actually does not involve StatCrunch, this first part of the question. This is just a matter of reading the screen. I'm sorry, scratch that. It does involve StatCrunch. It does not involve empirical rule. This involves just reading the screenshot here. They're telling you, this little statement here says the probability that somebody's IQ would be between 84 and 128 is right here. So this just means reading that screenshot, it would be 0.8259 or about 82.6%. So that first question actually did not involve empirical rule. It was just from reading the screenshot from StatCrunch. Now, B says, what is the probability that a randomly selected person would have an IQ score less than 84 or greater than 128? So that would be this region and this region. So where the red is 84 and 128. And I know that because of this information given to me from the output from StatCrunch. So notice that this would be the complement of the probability we just looked at. So this would be 1 minus the 0.8259, whatever that is. That's just the complement of the previous probability. I really want to get into the empirical rule because that's the stuff I think that's most important. So look at C. C says, what percentage of IQ scores would be between 85 and 115? Now, ask yourself, can this be done using the empirical rule? And by the way, any question on the test involving this kind of like a normal distribution, you don't have access, remember, to StatCrunch on the test, so it has to involve empirical rule. And that's why I think having this graphic on your index card is so important. So between 85 and 115, that would be 1 standard deviation below, 1 standard deviation above. So using the empirical rule, that would be 68% of your data. Between 70 and 130, notice that's 2 below and 2 above. So that would be 95% using the empirical rule. 100 to 115. Now let's talk about that. 100 to 115 would just be this little window right in here. So that's why I say if you have this on your index card, you can figure out any interval they ask you for. Notice that that would just be 34%. Okay, and then F says 70 to 100. All right, so 70 to 100, that would be this region and this region. So go back to your breakdown. That would be what? That would be 34 plus 13.5%. That's why I want you to have that on your index card. That'll make these questions go really, really quickly. 34 plus 10 is 44 to 47, I think, and a half is what that is. And then less than 70, let's take a look at that. Less than 70. So 70, notice, is 2 standard deviations below the mean. So 2 standard deviations below the mean. Less than that is only 2.5%. So that interval below 70 would translate to 2.5% of the entire data using the empirical rule. Let me see, I've got a couple more here. Let's go down to number 15 and then we'll look at chapter 7 in the last video. It says the arm spans of the male Western gorilla are normally distributed. The middle 95% goes from 91 to 102. They want to know what is the mean and what is the standard deviation. So draw a little picture here and let's use the empirical rule. Mu we don't know, but we know that the middle 95%. So notice that 95%, remember from the empirical rule, is 2 standard deviations below to 2 standard deviations above. So they're telling you that that spans from 91 to 102. And they want to know what is the mean and the standard deviation. There are a couple of ways you can figure this out. I think to get the mean, the easiest way to do it is to just find the average of those two numbers, 91 plus 102 divided by 2, because notice that the mean would be right in the middle. So I'm getting 96.5, and that looks about right. 96.5 would be smack in the middle of 91 to 102. To get sigma, the standard deviation, the video is going to cut me off, so let me finish this in part 3. I'll see you in just a moment.